Hello everyone and welcome back to Machine Learning Techniques Lecture 4, where today we are going to learn about classification. So what is classification? What is the goal of classification? So basically we are trying to differentiate between two or more than two different features or items that have multiple features of their own, which usually are to make a particular decision. For example, you have a bunch of emails in your inbox and you want to know which of them are spam or which are not spam based off certain keywords, which can be the features, or whether a customer is going to buy or not buy an item based off the seasonality of that item, or whether the customer is a regular customer or not, or so on. So today we are going to learn three different strategies computers use to make these decisions. Now let us look at the first algorithm, which is the k nearest neighbors algorithm or the KNN algorithm. So what is this algorithm? Basically, a new data point is classified based on the majority class of its neighbors. So what does this mean? Let's say you go to school or college and you have a lot of close friends, and majority of your friends like a particular genre, let's say action movies. Then it's very much likely that you also will like action movies and are going to watch an action movie. Or to put it into a general data sense, when there is an unknown data point and there are multiple classes, depending on which other data points are closer or are within the closest distance of the new data point is assigned to that particular class. So here's a visual example. You know, you have the new data point, which is the green circle, and so k here basically means that you are to select what is the value or how many nearest neighbors to compare across. So here you have a green circle, and let's say we take the k value as 3. So the three closest neighbors are two red triangles and one blue square. So which means automatically this is going to be assigned to the red triangle class. But as you can see, there is one small backdrop in KNN. Let us say we increase the k value to 5, and you increase it to 5, or the distance increases, you can notice that there are 3 blue squares and only 2 red triangles. So this can form a change in class. Anyway, let's look at overall how k nearest neighbors algorithm works. So this is a new point and there are two different classes, and let's say we take the k value as 5. So it compares across each and every single point in the data set. And once it does this, only then it finds the k nearest neighbors and then accordingly sees which class is majority within those value of k. So this distance is usually measured by Euclidean distance. So when to use KNN, what are the pros and cons of KNN? As you can see, it is very simple to understand and easy to implement as well. And you do not have to train on any data. You have the data automatically, you can just run the model. But the problem is it is slow on larger data sets and multiple dimensional data sets. This being, it has to calculate the distance to each and every single point for each new prediction. So it takes a lot of time for big data sets. And very importantly, it needs the features to be on a similar scale. For example, you are trying to find the correlation between age and salary for a person in a company. And the salary is going to be in thousands and the age is going to be in tens. So there's going to be a huge stretch across the x and y axis, because of which the features or the nearest neighbors algorithm may not work properly unless they are scaled to or normalized. Now moving on to the next algorithm, which is the naive Bayes classifier. So what is the naive Bayes classifier, or what is the Bayes theorem? So basically, this is the Bayes theorem, which is the probability of a hypothesis happening given that a particular evidence or truth is true is the probability of the evidence happening considering the hypothesis is true into probability of the hypothesis happening divided by the total probability that the evidence is true. So this is a very, very important formula based on which the naive Bayes classifier classifies. So what is this? How does it work? So let's say there has been a crime scene and there are 5 different suspects. So you're going to see different clues. There's going to be a footprint, there's going to be a fingerprint. So there's going to be a probability or a match for each and every clue with each and every suspect. So now in the end, when we multiply up all the probabilities, you will find out that the person with the highest probability is the most likely suspect. So that is how this basically works. So why is it called a naive Bayes classifier? Why is it naive? So the algorithm makes a naive assumption that all the features, or as in the previous analogy, clues are independent of each other. This usually in a general and real world scenario isn't true, but it works surprisingly very well because it simplifies things a lot. So let's take a more practical example where this is usually used. In your email inbox, you have multiple mails and you want to know which of the following is spam and not. I think in your Gmail, you can always see that there's a spam folder which automatically contains mails. You do not have to do anything and send them to spam. You have the option to, you don't have to. So how does this work? It's basically based off certain keywords that it recognizes and figures out if it's spam or not based off the probability. For example, the words free, offer, and winner most oftenly lead to spam. Whereas, let's say, meeting or timing or classes are going to be any work related words. So those are most likely going to be not spam. So generally, this is how the questions or numericals for naive Bayes classifier are going to be asked. They're going to give you this table and ask you to find out what is the probability for yes and no for each and every particular weather condition when you're going to play a sport. So first thing you do is to convert everything into a frequency table, and from the frequency table you just try to find a basic likelihood table or a basic probability. How often is it overcast, how often is it sunny, how often is it rainy, and generally how often do we play and how often do we not play. But this is not going to give us any information on whether at a particular whether we are going to play or not. So that is going to be done by the likelihood table 2, where we find out what is the probability considering it is overcast that we play, or what is the probability considering it is overcast that we do play. So based off the weather, there's going to be a probability for yes and a probability for no. So when do we use this naive Bayes classifier? What are the pros and cons? So since it's going to be majorly only multiplication and division, it is very, very computationally fast. And it works very well with text data, as I had shown earlier with the example of spam filtering of your emails. And again, requires very, very less training data. So what are the problems? Well, since it's naive, I did tell you that it does work surprisingly well, but at the same time, it is not perfectly accurate as well. And there is something called a zero frequency problem. For example, if a word ever exists, if something doesn't exist in the training data, then automatically it is going to become zero. So how do we fix this? This is fixed with something called Laplace smoothing, which basically just adds +1 to the numerator and denominator to ensure that no data has zero probability. This is basically just a simple normalizing technique which you will probably be learning in other subjects or statistics. Now moving on to the decision tree algorithm. This is a very, very powerful algorithm. So how does this work? So basically we try to ask a question, and based off the answer to that question being yes or no, or any numerical greater than this number or less than this number, You split the data and accordingly make the next decision based off the feature. So each and every node is going to be a feature. So basically, it is a model that predicts a class by learning simple decision rules arranged in tree-like structure. For example, let's say you're playing a game where you ask yes or no questions to figure out what is the object. Give me questions like, is it a bread box? Is it an animal? Does it live in water? So with each and every question, you eliminate multiple options and in the end reach the final answer. So this is a very simple example. So the goal is in the end to predict whether you're going to play tennis or not based off the weather. So what is the outlook? There are multiple options: sunny, overcast, and rain. So is it sunny? Okay, it's sunny. If it's sunny, what is the humidity? Is it high or normal? So based off high, then it's no. If it's normal, then yes. And accordingly, if it's overcast, it's yes. If it's rainy, okay, then how is the wind? If it's strong wind, no. Weak wind, yes. So the algorithm automatically learns which questions are the most important to ask first. So now, similarly, this is another example. What kind of car are people more likely to buy based off their age or based off the car type or based off the number of children they have. So this is all done from a big data set. So now, how do we reach at these values? Greater than 30, lesser than equal to 30, and how do we know how to put car type first, or if there's a very very long table, how do you prioritize which feature is the most important? This is done with something called either Gini index or entropy. These two are responsible for splitting or finding out at what value you are supposed to split a particular class or a particular feature. So what is a Gini index? So Gini index basically measures impurity, or how much there is a change in behavior at a particular point. So this is the formula for the Gini index. And entropy basically measures how much disorder there is in a data set, and accordingly again splits the decision tree. So both of these are different methods within the decision tree to make decisions. When do we use this decision tree? What are the pros and cons of decision tree? So number one, it's very very highly interpretable because you can easily visualize the decision tree and even show them at what importance each and every class is, or at what point you split. People can easily understand how the model makes decisions. And it doesn't require feature scaling, and it can handle both numerical as well as categorical data. Now, what is the problem? It is prone to overfitting. A tree can grow very very deep. Let's say you have 20 features. You don't have to have a tree with 20 different questions or 20 different levels. Beyond a point, few features may not be as relevant or as important, or it may just be noise, or those features may just be any random correlation which actually doesn't have correlation to the results. So basically it's memorizing or overfitting. So this can be solved by pruning the tree or limiting the length of the tree. And another con is that it's a bit unstable. So small changes in data can lead to a completely different tree being generated. So in summary, we have looked at three different algorithms: KNN, which works based on the vote of neighbors, and usually it is best for simple problems or finding similar items and is easy to understand. Naive Bayes is based off probability of each and every feature. It is best used for text classification such as spam filtering and is very very fast. And decision tree is based off a flowchart of questions and usually best used when you want to explain any decision and is very highly interpretable. Thank you everyone, and see you in the next lecture.